So today I'm going to talk about three different forms of a parabola, something that we routinely call vertex form, standard form, and factor form. Starting with vertex form, I think it's appropriate for us to identify the position of the vertex here. So on my graph, I can see that the vertex is going to be there, which puts it at -2, comma, -4. So we'll start with that. Now that -2, -4 corresponds to my vertex form, if I remember that the +2 actually goes in the opposite direction and the -4 actually moves down. So all of a sudden, my equation for vertex form matches my position for vertex. Now I'm going to use this equation and plug it into my area model by writing it out as x plus 2, x plus 2. That takes care of the square and subtract 4 at the end. I set up my multiplication and I have x times x is going to give me x squared, 2x, 2x, and 4. I'm going to go ahead and add the middle pieces. Once I do that, I now end up with a new form that reads x squared. 2 and 2 makes 4, so 4x, and 4 minus 4 is 0, so this is 0. This is now my new standard form, which I'll write up here. So now I'm going to say that I have x squared plus 4x plus 0. And by the way, it would also be acceptable for me to rewrite this as x squared plus 4x. Okay, so one or the other would be fine. I am going to purposely use the top one, which is this one, so that I can effectively use my big X strategy. So multiplication means this is 0. My addition means this is 4. So keep in mind, I'm going to need something that multiplies to make 0. So, and at the same time add up to 4. So these are the appropriate numbers. Once it's written like this, I write it over 1. And now I have my two answers that I want, which will become factor form. So this now turns into 1x plus 0, and this turns into 1x plus 4. Given that this is multiplication, and now I can rewrite this as saying 1x plus 0 and 1x plus 4. I'm going to use my area model to see what happens when I multiply that out. So I'll put that in here as a 1x, and this is 0. And this will be 1x, and this is 4. This is still going to give me x squared. That's what this means if I multiply. This is 0x. This is 4x, and 4 times 0 is 0. Notice that I'm going to add, just like I did with my original area model. And when I add, I now end up with an answer of x squared plus 4x plus 0. One additional note that I want to include here, though, is that I am allowed to rewrite my factor form like this. So I can say x times x plus 4, and I can now set that equal to 0. Now, if I do that, that tells me that either x is equal to 0 or x plus 4. X plus 4 is equal to 0. Okay. Now, x equals 0 is one solution. X plus 4 equals 0 can only happen if I now have -4, -4, And if, for example, I can say that x is equal to -4. So with that being said, I have two possible answers, this and this. Now, how does that translate to my graph, or why is that an important thing to know? Well, x equals 0 would be a point right here. X equals -4 would be right there. So it turns out that by knowing my factor form, I can now figure out when my curve, my parabola, when will it cross over onto the x-axis. We call those roots. We sometimes call those solutions. Okay, so that's one aspect of this kind of solution. Okay, so with that being said, let's move on to the second example. You're going to notice that in the second example, I already have standard form. So I'm going to use standard form and I'm going to do two things. I'm going to use the answer and I'm going to use the answer so that I can find my vertex form, but I'm also going to use it so that I can find my standard form. I'm sorry, my factor form. With that being said, I'll start here with vertex form. I happen to know my vertex is at -2, -1, so I'll say that's -2, -1. So I expect my vertex form to have that combination of numbers to some extent. I'm going to say x squared. I'm going to say 4x. Remember, 4x has to be distributed between these two pieces. So basically what we do with the 4 is we cut it in half, so that becomes 2x and 2x. The 3 is extra, so we say plus 3 on the side. This gives me enough to start setting up my equation. So look at what I'm going to have. That can only happen if this is x plus 2. 2 times 2 is 4. Now, I'm never allowed to give myself a number without balancing it out. So what that means is I'm going to have to subtract 4 right here. Once I do that, I am going to now start with this answer above. And I'll say that I now have my vertex form as x plus 2. This is the square. And 3 minus 4 is -1. Now, just to take a look, I realize that the plus 2 goes in the opposite direction. I made that distinction last time. The minus 1 goes down. So now this and this, they basically are giving me the same piece of information. Okay. Now to continue, I'm going to come over here and I'm going to put a 1 right here and I'm going to multiply. So that means 1 times 3 is 3. So I'll put the multiplication there. The addition I'm going to put in the bottom, that's 4. So I want two numbers that multiply to give me 3 and at the same time add up to 4. So that's relatively easy. I know that 1 times 3 is 3 and 1 plus 3 is 4. So now I rewrite this over 1 and I have my first answer as 1x plus 1 and my second answer as 1x plus 3. Here are my two factors. I'll write that down. So here I have the x plus 1, x plus 3. I'm going to use my area model one more time just to check to see if it matches with my other equation. So I multiply normal, and that is my x squared, that is 1x, that is 3x, and 3 times 1 is 3. I'm going to go ahead and add here in the middle. So if I add there in the middle, I can now go ahead and set it up as x squared plus 4x plus 3. And that, of course, matches with my original version of the equation. All right, just to double check one last thing, I'm going to do the same thing I did earlier. I'm going to set x plus 1 and set that equal to 0. Or I'm going to set x plus 3 and set that equal to 0. I realize this is negative 1. So x can only be that if it's negative 1. This is negative 3. So x is equal to negative 3. Therefore, these two numbers somehow correspond to my picture. I realize that that would be here and that would be here. So those are my roots. Okay. And last but not least is what happens when so let's see here. There we go. What happens when it looks like this? What if I am being given the factor form? So if I'm being given factor form, I will basically use that to see if I can figure this out and then use this somehow to see if I can get this part. All right, so let's double check a few things. Well, my vertex appears to be at 1, 2. So that appears to be at 2, negative 9. All right, so let's see what we can do. See if there's anything here that I can use. I think what I'm going to do first, though, is I'm going to come over here and I'm going to set um, x minus 5 equal to 0, or the x plus 1 is equal to 0. I'm going to add 5 to both sides. That means x is equal to 5. Or subtract 1 from both sides. That means x is equal to negative 1. And I'll quickly notice that that will be this number, this number. So I already know these two pieces. All right, so let's continue. So in here, I'm going to write as x minus 5. And here I'm going to write x plus 1, multiply like normal. So this will be x squared minus 5x. This will be 1x minus 5. So what does that mean? Well, I'm going to add like I normally would. So let's see if I can do that. Okay, so I'm going to add those pieces. I notice that I now have x squared. Negative 5 and 1 makes negative 4x and minus 5. What that tells me is that that is my standard form, which I'm going to copy up here. I'll say x squared minus 4x minus 5. Now, they're asking for the axis of symmetry, so I automatically am going to do this. I'm going to say let a equals 1, b equals negative 4, c equals negative 5. Axis of symmetry gives me negative b over 2a. And so that means that it's going to be the negative of a negative 4 over 2 times 1. Okay. Negative and negative is positive, so this turns into 4 over 2, because 2 times 1 is 2. I go ahead and I divide. So it turns out the x, let me write this down. It's not writing. Let me see here. So x is equal to 2. Okay. Now, with that being said, um, next thing I'm going to do, I typically use this number here, this response, and I plug it in for x. So I'm going to practice that real quick. So in here, I'm going to go ahead and now rewrite this. What's going on here? Like this. And I'm going to rewrite it as, let's see here. I'm going to rewrite it as something squared uh, minus minus 4 with something, and then minus 5. The 2 goes in here, so I'll put a 2 in there. So let's double check here. All right, so now I gotta fix this real quick. I'm gonna type in here and basically set it up. So that's a 2. That's a 2. That's a 2. That makes this a 4. This makes this a minus 8 minus 5. Now 4 minus 8 is going to be negative 4 minus 5. And that, of course, is negative 9. So that tells me that my y value is negative 9. But the reason that's important is because now these two numbers conveniently match the position of my vertex. Okay? So now I have something to verify that I have this correct. All right, so how can I use this for my vertex form? Well, I'm going to plug it in here. I'm going to say that I have x squared. The minus 4 on my original problem has to be cut in half because it has to be distributed between these two pieces. So that becomes negative 2x, negative 2x. The minus 5 is going to go on the side. And so now this turns into x minus 2 x minus 2. This turns into a 4, which means this is now going to turn into a minus 4. All right, I take this piece. This is what I'm going to use for my equation. So I now say that I have x minus 2 squared. And it turns out that if I try to, let's do this correctly, the -5 and the -4 turn into -9. So this becomes -9. And that takes care of all of my pieces. Now, the -2, if it's going to continue with that opposite movement, that means this moves over this way. -9 means it moves down this way. All of that confirms the position of this vertex. And those are the three possibilities of all of this work. Okay. So, other than that, hopefully this helps out. Send me any questions through the Schoology. Thank you.